Hello.
Hi.
Hey, hi. Am I audible?
Yeah, I can hear you.
Yeah, cool. So, before begin your class for chemistry, I just wanted to have a brief introduction of yours. Means, what's your hobbies and why? Means, why do you like the science subject? What is the reason behind that? So, you can begin now.
Sure. Um, okay. I guess I like reading. And the reason I like science, well, I like biology a lot more than I like chemistry.
Okay, cool.
Uh, yeah. I don't know, I guess I'm just interested in it, but
Okay.
I'm a little less interested in chemistry, which is why I need to do tutor.
That is why you need me to make you interested. To inculcate the interest level inside you. Definitely, I'll make that. That is my main job, right? Yeah. So basically, you and Divya, I guess you both are in the same class, right? Same standard, and you are also having the IBHL.
No, I'm SL.
Okay, IBSL. Cool. So today, before begin to class, basically I'm myself that I'm a Ram sir, and I am passed out from IIT Kanpur, and I am taking classes for chemistry since last 10 years. And in India we are having a major part is IIT-JEE. In India we need to cover the syllabus for IIT NEET, but I am taking classes for the student across the globe like Canada, UK, London. So I'm also dealing the curriculum of IBSL, IBHL, IBDP, all kind of things.
Okay.
Okay. So how means what you like most about the Ghana and Angola? Because see, I can see that you are. I think you would have been born and brought up in India, right? But you are
No, actually, I was born in Moscow and I haven't lived in India for a long time. I've only lived in India for like 3 years.
okay. So do you like India, or you don't?
I like India. I like India.
Okay, cool, cool. Okay, yeah. So I'm going to share my screen.
Sure.
So today, which topic you would like to study? Would you like to study?
Um, we could do anything, really. At some point, I do want to learn the new unit, sorry, that we haven't learned yet. Like Unit 5 and 6, which is, I think, energetics.
Okay,
And
energetics.
yeah, I haven't learned that yet, though.
Okay, okay, cool. So, by the way, your good name is Chinmaya. What's a good name? How can you spell that?
My name is Chinmayi, but
Chinmay. Yeah.
my friends usually call me Maya. You can call me anything. Chinmayi
Okay.
or Maya is
Okay.
fine.
Maya is a very, it's a, in India we are having a movie of the Kajol. In that movie, Kajol was having this name Maya, and
Really?
yeah, and the meaning of Maya is like money.
I thought it meant illusion.
Oh, delusion is a kind of a kind of meaning, but the real meaning of Maya is a kind of wealth, kind
Oh,
of prosperity.
okay.
Okay, Maya ID. So your is IBSL, right?
Yes, that's all.
Okay, cool. So this is me, your Ram sir. I'm famous in India as RJ sir. Okay, so you can call me RJ or you can call me Ram, whatever you would like to call me.
Okay.
Cool. Okay, so we will begin with the energetics. Cool.
Yes.
Okay. So what do you mean by energy? How can you define the energy?
Energy.
Yeah.
It's like, I'm not sure.
Okay. Okay. So means suppose you had your lunch. You had your lunch. After lunch, you got the energy. You got the some
Yes.
capacity in body to do the work, right? So energy is
Yeah.
something which you can you can derive the work. You can utilize your energy by doing the work. So energy is a kind of random motion of molecule in the system. It's like a random motion of molecule in the system to generate useful work or non-useful work. But anyway, you are doing the kind of work. So energy
Okay.
and work both are interrelated. Okay.
Okay. Yeah. Energy and work and both interrelated.
So in this thermodynamics, we deal with the macroscopic object not in the quantum level, object in the macroscopic, like a big system. Okay. So this is known as the thermodynamics. Thermodynamics and thermochemistry. Okay. So thermodynamics, we are having a kind of two state function: work, heat, work and heat, W and Q. Okay. This work and heat is the kind of energy. Both are the function of energy. Both are the function of energy, and it is useful. It is useful for displacement of molecules in the system and surrounding. Okay. So
Yeah.
these two factors are responsible for the displacement of molecules in the system or the surrounding. Like, so if I talk about the universe, it is a combination of system plus surrounding. Okay. Are you any doubt in this? Are you clear with that?
Yes.
Okay, cool. So there are the first law of thermodynamics, second law of thermodynamics. Before that, I'm going to give you a little detail about the quantities. There are the two kind of quantities in thermodynamics. One is called extensive quantity. One is called extensive. Other one is called intensive. Have you heard about this parameter?
No.
Okay, I'll explain. Extensive means a quantity which depends on the size of system and the mass of system.
Okay.
Okay, the quantity which depends on the size and mass of the system.
Okay.
Mass of the okay. So my handwriting is quite visible to you, or do you feel it's like a doctor handwriting? It's okay.
I can kind of read it. It's fine.
Okay, the quantity which depends on the size and mass of system. I will
Okay.
I will try to spruce it up a little bit more adjective. I will give the more kind of pressure on the hands, so it will be more smooth. Okay,
Yeah.
cool. Okay, what about
Yes.
intensive? The quantity which does not depends. The quantity.
Just 1 second. Sorry.
Yeah,
Just 1 second.
yeah, please.
Hi. Sorry.
Yeah,
Continue.
right. The quantity which does not depend on size and mass of the system. Mass of the system. So now you will ask, sir, what are the examples? So do you know that volume? Can you tell me
Yeah.
volume falls in which category? Extensive or intensive?
Volume falls in extensive.
Extensive, definitely. Because if we are having the 1 liter vessel, so volume will depend on the size of the vessel. If we keep on changing the size of vessel, volume will be keep on changing. Right?
Yes.
Okay.
Yeah.
So for extensive quantities, we have examples. For extensive, we have the volume. Okay. Volume depends, and energy also depends. Energy also depend on mass. You know, E is equal to mc square. E depends on the mass. Energy depends on
Okay.
the mass. Heat depends on the mass. Entropy
Okay.
depends on the mass. Gibbs free energy depends on the mass. Okay? Mole
Okay.
depends on the mass. Moles obviously depends on the mass, right?
Yes.
Okay.
Yes.
So these are the examples of extensive, right? But
Okay.
if I ask you, what about density? What about density? What about refractive index? What about pH? What about EMF, electromotive force, EMF of cell? Whether these quantities are extensive or intensive.
I think density would be extensive, right? Because it's mass and volume.
Mass by volume. So I'll tell you one thing. If a quantity is the ratio of two extensive quantity, a quantity which is the ratio of two extensive quantity 1 and extensive quantity 2. So it will always be the intensive one.
Okay.
The ratio of two extensive quantities will always be the intensive ones. And moreover, you can also imagine, you can also feel, see, my teaching will be based on the cognitive domain, affective domain, and psychomotor domain. So cognitive domains means now we are in the first phase, like understanding, applying, analyzing. After that, affective means you have to feel the chemistry. The moment you start feeling the chemistry means you are gradually increasing, gradually making your concept clear, right?
Yeah.
So you can feel, suppose you are having water, the density of water inside a vessel will be also one, and the density of water inside a cup will also be one. The density of water inside a small glass will also be one. Density of water will not be changed irrespective of size of the system. Do you imagine that? Can you imagine that?
Yes.
Yeah. Water, if you take water will be the density of water will be remain same irrespective of any size of the system.
Okay.
Yeah. So density is intensive, and moreover it is the ratio of mass by volume, extensive. So overall it will be intensive. What about refractive index? Have you ever heard about this term, refractive index, in physics?
I don't
Okay.
take physics.
Okay. You don't have physics?
I don't take physics.
Okay. Mhm. So you have you seen the glasses?
Yeah.
Yeah.
Yes. Yes.
Yeah, right. So the glass, if you are any light beam is falling on the glass, there will be some kind of reflection,
Yeah. 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 Yeah.
and that reflection will happen through a particular angle theta.
Yeah.
That angle is called refractive angle, and this property of glass is called refractive index.
Okay.
And the property of glass, this property of glass will be same for 10-meter length glass or 1-meter length glass. Irrespective of any size of glass, this property of glass will remain same. Okay. So refractive index is intensive quantity. What about pH?
pH is an intensive quantity.
Yeah, because it's like a concentration, and
Yeah.
concentration is nothing but the ratio of mole by volume. Mole is
Yeah.
extensive, volume is extensive, so it is intensive.
Okay.
What about EMF of cell?
Unit of
EMF of cell, electromotive force or electrode
electron.
potential.
I'm not sure I know what that is.
Okay, cool. Do you know this formula? Delta G is equal to minus NEFs. Have you heard about this formula? Minus NFE cell.
No, I have not.
Have you studied this concept called electrochemistry? Have you studied electrochemistry? No.
No, I haven't. No.
Okay. This comes from the electrochemistry. Okay?
Oh, okay.
So
Yeah.
here delta G is the Gibbs free energy. Delta G is the Gibbs free energy. N is the number of electron exchange, number of electron. F is the Faraday constant. E is the E is what? Electromotive force of cell.
Okay.
ठीक है?
Mhm.
So you can say NFE, delta G is equal to NEF. So E is equal to delta G upon NF. ठीक है? So
Uh-huh.
E directly depends on the delta G because number of electron and Faraday constant both are constant. Both are constant. So E is directly proportional to the Gibbs free energy. So when once E depends on the energy, it is extensive quantity. It is extensive.
Ex-
Yeah. Cool.
Yes.
Okay. So these are the things that you have to understand.
Mhm.
Got it? Got it?
Yes.
Okay.
Yes.
Okay. Now we will begin with the types of thermodynamic process. Types of thermodynamic process. So how many types of thermodynamic process exist? Types of, yeah.
For dynamics forces exist.
Do you have the idea about this thermodynamic process type?
No.
Okay. These are the isothermal. First process is isothermal. Isothermal. The second one
Okay.
is isochoric.
Okay.
The third one is isobaric. And the fourth one is adiabatic.
Okay.
Cool. Okay.
Yes.
Now, what do you mean by the isothermal process? Isothermal means temperature constant. When temperature of the system, temperature means T of the system remains constant. Remains constant. That is called isothermal. What is isochoric? When volume of the system remains constant. Remains constant. This is called volume constant, isochoric. What about the isobaric? When pressure of the system remains constant. What about the adiabatic? What is the adiabatic process? Any idea about that? Okay. So have you ever heard about the adiabatic? What is adiabatic? Have you ever heard this term, adiabatic?
No, I have not.
Okay. So adiabatic process is a kind of heat transfer. So when there is no heat transfer between system and surrounding, there is no heat
Oh.
transfer. When system is an isolated system, that is called the adiabatic process.
Okay.
When there is no heat transfer takes place. Transfer between system and surrounding. Between system and
Surrounding.
surroundings. ठीक है? Cool. Got it?
Yes.
Okay, wonderful. So now when temperature is constant means T1 equal to T2 if the process is happening in the two particular path A to B. So from A to B, we are moving from A to B. So T1 equal to T2, or you can say del T or dt equal to 0. Right? When temperature is constant means del T is equal to 0.
Okay.
When volume is constant, del V equal to 0, or you can say V1 equal to V2.
Okay.
When pressure is constant, del P is equal to 0, or you can say P1 equal to P2.
Yes.
And when no heat transfer takes place, that means del Q or dQ equal to 0. So Q1 equal to Q2. Right? Any doubt?
No.
Okay, cool. ठीक है. So now you see that there is an isothermal process, means temperature is constant. So when temperature is constant, that means that time what will happen? Do you know the first law of thermodynamics? Have you ever heard about this first law? So I will
No.
explain. I will explain the first law of thermodynamics. What is the first law of thermodynamics? This law is based on the law of energy conservation. Law of energy
Conservation.
conservation. Okay? If it's a system, this is a system, and you are supplying the heat supplied to the system, or heat liberated from the system. Heat liberated. Just a minute. Yeah, heat liberated means you are getting heat outside of the system, or work applied on the system, or work done by the system.
Mhm.
Work done by the system. Cool. So when there is a heat supplied or heat liberated is Q, and work supplied or work liberated is W. So the sum of heat and work is constant, and that is equal to the internal energy of the system.
Okay.
So I believe when your chemistry is good, so do you have a dream to become a doctor? You want to become a doctor?
I'm not sure anymore. I thought I wanted to become a doctor, but I don't know anymore.
Okay, because this COVID, when the COVID started across the globe, so the value of doctor is very high and it is very respected job. So and since you are good in the biology, so you can think of it.
Yeah, I could think of it.
Right.
That's
So for getting a good seat in the Indian MBBS college or across the globe, you need to have a command in chemistry, biology, and physics, all three. Particularly in India, you need to have these three subjects.
Yeah.
Right. So Q plus W is equal to U, where Q is the heat, W is the work, and U is the internal energy.
Okay.
This is the first law of thermodynamics. The sum of heat supplied or heat liberated plus work done on the system, work done by the system, equal to the internal energy of the system. U
So
is the
heat, Q,
yeah
internal heat.
Q is the heat internal. Q is the heat. Any more other doubt? Q is the heat. Either you can heat supplied in the system or heat liberated from the system. I can give you a real life example. Suppose
Okay.
you are having a LPG cylinder.
Okay.
And the LPG is leaking.
Okay.
Okay. And you come after 2 hours, you open the light of your kitchen, and there is a sudden spark. Right? Because of the spark, it will get ignited. The moment there is a combustion, there will be a kind of blast. So when it's a kind of blast, there is a liberation of heat. Temperature will sweeten up. Okay, temperature बढ़ जाएगा, temperature will be increased. Right? So that is the kind of heat liberated.
Liberate.
Right? But if you want to break calcium carbonate, lime, if you want to break limestone, then you have to provide heat in order to decomposition of limestone into the calcium oxide plus carbon dioxide gas. So this is the endothermic process.
Yeah, because
So,
heat is
supplied.
Yeah, supplied.
So delta H is equal to positive. Here delta H is equal to negative.
Yes.
I think it's clear to you.
Yes.
Cool.
Yes.
Okay. So Q plus W is equal to E.
Yeah.
Q is the heat, W is the work.
Mhm.
Now, in the terms of work, I will define the work. Is that clear to you?
Yeah.
So After the class, I'll share the recording as well as the PPT.
Okay, thank you.
So you can access the recording anytime you want. Right. So what is the formula of work done? Force into displacement. Right. It is the force into displacement. And suppose I am having a cylindrical volume V and the cross sectional area is A. Earlier, there is a gas is inside. Gas is inside the volume, right?
Okay.
So in thermodynamics, we discuss only the gaseous work. We don't discuss the work like mechanical or electrical work. Won't be discussed. Only we discuss gaseous work. Gaseous work means PV work.
Yeah.
Cool. So
yeah,
here we are having distance D. Okay. Once you applied the external pressure, so molecule will expand.
Yeah.
And there will be a displacement called d dash.
Okay.
Okay. So now you can write like this. What is the pressure formula? Force upon area. This is the formula of pressure, right?
Yeah.
So force becomes pressure into area. Now you have to put this value of force in the equation first, and you can derive the formula of work. So now force is equal to pressure into area into displacement. Okay. Earlier the volume was like V1. Now volume is like V2. After expansion of gas, volume is V2. Earlier it was V1. So what will be the delta V? Delta V equal to V2 minus V1. Right?
Okay.
And what is the formula of volume? Volume is the area into cross-sectional length. Area into cross-sectional length. Right?
Yeah. Yeah.
I think you know this formula.
Yeah.
Yeah. Okay, cool. So now you can take this as a L. You can take this as a L. Earlier it was length L1. After its length L2. After the expansion, the length is L2. Cool?
Yeah.
Okay. Now we can write like this. W is equal to pressure into delta V. Area into displacement is equal to delta V.
Okay.
So now we got the formula of the work done, gaseous work done. It's a gaseous work, or we can say PV work. It's a pressure volume work.
Pressure volume. Yeah.
Right. Any doubt? Any doubt in this?
No.
Okay. So generally we are using P internal, but it is not feasible to measure the all pressure of the individual particles, because all the gaseous individual particle will exert the pressure on the wall of container. They will hit the wall of container and they will exert individual pressures. They all will exert individual pressure.
Yeah.
Okay. Right?
Yes.
Okay. So it is not possible to measure the value of P internal. So if we want to measure the whole value of P internal, we have to put a particular pressure gauge outside of the vessel. So that will be the P external, because as per the Newton's law, third law of Newton's, there is always a reaction of every action. Right?
Okay.
So when gaseous molecules are applying the pressure on the wall of container, there will be a pressure from the external side, and that will be the P external. That will be the P external. And can you see the direction of pressure? The direction of P internal and P external are same side or opposite side? The direction.
They're the opposite side.
Yeah, they are just canceling each other out. So it is opposite side. So
Yeah.
P external means it is minus P external. Okay? P internal is equal to minus sign will be there because the direction is opposite.
Okay.
So W will be minus P external delta V. This is the final formula. Any doubt in this?
No. No.
Okay, so you're clear, right?
Yes.
I have asked about Divya. I have asked Divya about you. Divya told that Maya is quite a kind of girl who is quite, interrogating, mean believe to questions a lot. But you are not asking any single question to me.
If I have questions, I'll definitely ask them.
Okay, cool. Yeah. So this is called the work done, gaseous work.
So right now we're only focusing on like energy and like work and things like that, right?
Yeah, currently we are focusing on the first law of thermodynamics, and there is an entropy. Entropy comes after the first law.
Yeah, because I'm looking at like my syllabus for like whatever. And so I'm just trying to figure out where we are right now.
Yeah. So can you just can you just tell me your path of the syllabus? But what are the things are in the syllabus?
Yes. So it says I have 5.1, 5.2, and 5.3. 5.1 is the enthalpy changes from chemical reactions can be calculated from their effect on the temperature of their surroundings. So it's just about measuring energy changes. And then 5.2 is basically about chemical transformations, which is the first law of thermodynamics, which is what we just did. And 5.3 is energy is absorbed when bonds are broken and is released when bonds are formed.
Okay. Okay. Cool. So okay. We will begin with the enthalpy. After just we will finish this first law of thermodynamics. We can introduce the enthalpy. Enthalpy is the function of first law. Okay.
Okay.
So have you got the work done?
What? Yes, I have. I have.
Yes. Okay, cool. So now, first law of thermodynamics says Q plus W equal to 0. Q plus W equal to U, right? As you see in the isochoric process, the change in volume equal to 0. So W become minus P external delta V equal to 0.
Okay.
W become 0, right? So
yes.
Q plus W become U, W become 0. So QB equal to U. What is QB? Heat supplied at constant volume. Heat supplied at constant volume is the internal energy of the system.
Heat supplied at constant volume is the internal energy of the system.
Yeah, this comes from the isochoric process, because isochoric process is happening in the constant volume. When volume is constant, that time delta V becomes 0, so W becomes 0. When work done becomes 0, we can put the value of work done 0 in the formula of first law, then it equates the QV is equal to U.
Okay, so basically, because isochoric is when the volume is like constant, and then the volume is constant, and so therefore the work is equal to negative P, the negative external pressure, and multiplied by the volume, which is constant, and so it's equal to 0 because there is no external pressure.
No, there is no volume change.
There is no volume.
There is no volume change because V1 equal to V2, so delta V equal to 0. External pressure will be there, but there is no volume change.
So then it's 0.
Yeah.
Okay. Okay.
So,
yeah.
So heat supplied at constant volume is the internal energy.
Okay.
Okay. Now, just look this isobaric process. What about the isothermal? See, for ideal gases, just write a point. For ideal gases, enthalpy and internal energy is the function of temperature. So when temperature is constant, means when temperature is constant, so function of constant will be 0. If temperature is constant, the function of constant will be 0. Cool. Because function of constant, what is function? I will tell you. If it's a constant C, function of C, function is nothing but the derivative dy dx of C. Can you tell me, do you have the mathematics in your syllabus?
Of chemistry or just math?
Mathematics as a different subject.
Yes.
So I think you might have studied the like differentiation, integration, everything.
I don't we've studied functions.
Okay.
Yeah.
So the function of constant, if the function of constant always be 0,
Yeah, because okay, sure.
because it's a differentiation of constant, and the differentiation of constant always 0. Okay.
Okay.
So when temperature is constant, when T is constant, so function of temperature will be 0, means internal energy and enthalpy is 0. Okay, so if this is 0, so you can equate from the first law of thermodynamics. What first law? Q plus W equal to U. U become 0, so Q become minus W. So for isothermal process, there is direct change when the temperature is constant. So energy is directly changed into the work. Heat is directly changing into the work.
According to the first law of thermodynamics related to
yeah,
energy.
correct.
Okay.
Any doubt?
Yeah, okay. Wait, so I'm just gonna try to recap what you just said, just to make sure I understand. You just said that the temperature is constant because the function is constant.
The temperature is temperature is constant because of the isothermal. The property itself is isothermal. Isothermal means isothermal means iso means constant, thermal means temperature. So isothermal means it is a preconditioned process. This process is preconditioned. Already condition is being considered. We have considered the condition, then the process is the isothermal.
Okay, so isothermal processes only take place when the temperature is constant, which is what we want.
Right.
And therefore, okay, got it. Yes.
Got it. And now in terms of adiabatic, when the Q is constant, del Q is 0, del Q is 0, so Q becomes 0, so W becomes U. W becomes U. So this is just the first law of thermodynamics. Now we will take the process of isobaric, because isobaric process give you the idea about enthalpy. Okay, isobaric means pressure is constant. Pressure means P internal, not P external. P internal is constant. So QP plus W equal to U. QP plus W equal to U. Okay. In this case, nothing will. In this case, work will also be there. Heat will also be there. U will also be there. Nothing will be 0. Okay. Only we will write QP instead of QB, because we are applying the heat at constant pressure.
We are applying the heat at constant pressure.
Right. It's a preconditioned. Okay.
It's a applying the heat at constant pressure.
Now you can arrange this equation like this. QP becomes U minus W. What is U? What is W? W is minus P del V. W is minus P external del V. It becomes U plus P del V. It becomes U plus P del V.
Because it's negative. Yeah. Okay.
Yeah.
External pressure.
Yeah.
Sure. So does the pressure change to internal pressure because it's positive now?
Yeah, actually the internal pressure is constant. P1 equal to P2 is constant, but what the external pressure we are applying, it will be a constant external pressure. Constant external pressure means in the formula of work done, we don't have the change in pressure. We have only the change in volume. So even though the pressure is constant, the work done won't be 0. Work done won't be 0, because here we are having only P external. We don't have the delta P. We have the only P. Right? Got it?
Yeah, sure.
Yeah.
Sure, because we don't have the delta P, we have that P.
Yeah. So it become U plus P del V. It become U plus P del V.
Right. So QP is equal to the internal work.
Internal energy plus PV work.
Plus the pressure of the pressure of the volume.
Yeah.
Okay. Okay.
Got it?
Yeah.
Any doubt in this?
No.
Cool. That is really cool. So now I will tell you one thing. This heat supplied at constant pressure. Heat supplied at constant pressure is termed as a new term called enthalpy of reaction. This is the enthalpy of reaction. Heat supplied at constant pressure is the enthalpy of reaction.
Okay, is equal to the enthalpy. So what we have just done was the enthalpy formula.
Yeah, enthalpy. We have derived the formula for enthalpy.
Okay. Which is, and okay, just to clarify, that's the internal energy plus the pressure multiplied by the volume.
Yeah, QP is equal to internal energy plus pressure multiplied by the volume, U plus P del V. Yeah.
Okay.
And the QP is nothing but the heat supplied at constant pressure. That is called the enthalpy of reaction.
Okay.
So the formula of enthalpy comes out to be U plus P del V.
Okay.
So I think you got this question, right?
Yes.
So enthalpy becomes U plus P del V.
Yes.
Any doubt in this?
No.
Okay, cool. So now we got the equation enthalpy of a reaction. Now you can see that PV equal to nRT. Do you know that equation of
Yes.
state? Ideal gas
Yeah.
equation. Ideal gas equation. So you can write like this: P del V is equal to del NG/RT. Delta V is equal to del NG because volume is directly proportional to mole. Volume is directly proportional to mole when temperature and pressure is constant. That is called the Avogadro's hypothesis. Okay?
Right. Yeah.
So P del V is equal to del NG/RT. What is del NG? Del NG the gaseous moles of product minus gaseous moles of reactant. Gaseous moles of product minus gaseous moles of reactant.
Just okay. And okay. Right. And we have rearranged. Right. Okay. Yeah. Okay. Cool. Yeah.
Okay. Gaseous moles of product minus gaseous moles of reactant. Okay.
Yeah.
So del H become del U plus P del V. P del V. Or you can write like this: del H is equal to del U plus del NG/RT.
Okay.
Okay. Now I am writing a equation for you that COCl2 phosgene gas on heating produces carbon monoxide gas plus chlorine gas. So for this equation, what will be the relation of delta H and delta U? Whether delta H and delta H equal to delta U, delta H is greater than delta U, delta H is less than delta U, or delta H equal to 0. What will be the relation? Can you find out?
The enthalpy, the relationship between the enthalpy and the internal energy.
Yeah, because the relation is that delta H is equal to del U plus del NG/RT. You need to find out the del NG.
Which is the okay. Okay. So
Yeah. So what will be the del NG? Gaseous moles of product minus gaseous moles of reactant. So
yes.
del NG will be 2 minus 1. That is 1. So del H is equal to del U plus RT.
Wait, I have a really quick question. When you are doing the gaseous moles of something, we're counting the it's wait, sorry, what is it called? The thing here. Wait, let me just draw on the board.
Okay, you wanted to
This
draw
thing,
in
right?
yeah.
I can do it. So basically it's just 1 and 1. So we're adding up 2 and
Yeah,
then this is
right.
okay.
This is called the stoichiometric coefficient. And you know, stoichiometric
That's one.
coefficient is nothing but the mole ratio. Stoichiometric coefficient is nothing but the mole ratio. So the gaseous moles of product minus gaseous moles of reactant comes from the stoichiometric coefficient.
Okay. Okay, good. Great.
Got it?
Yeah. So the delta H is equal to the delta U plus 1. So the delta H is less than the delta
So
U.
delta H is obviously greater than the delta H is less because we are getting delta H.
Delta U is less than delta H.
Yeah, delta U is less than delta H, or delta H is greater than delta U.
Yeah.
Got it?
Yeah.
Okay, cool.
Yeah, I got that.
Okay, so now
Okay,
let's have the second question. Okay, can you just rub this
sorry.
board? Yeah.
Yeah, I can.
Okay. I am having this solid CaCO3 solid. On heating, it produces CaO solid plus CO2 gas. So what will be the relation of delta H and del U?
Okay. The delta H will be the delta U plus 1 again, so it'll be the same.
Let me check that. Delta Ng will be 1 plus 0 because it's a solid. It's a solid. So delta Ng will be 1 only.
Oh, okay.
Minus 0. It's a 1. 1 means delta H equal to delta U plus RT.
Okay.
What about this? N2 gas plus 3H2 gas equal to 2 mole of ammonia gas. So what will be the relation of delta H and delta U? This is the Haber's process, manufacturing of ammonia from hydrogen and nitrogen.
Yeah, but just to go back to the last question really quickly, delta H is equal to delta U plus 1?
Yeah, 1 RT.
1 RT.
Because product, we have the CO2, we have only one gas in the whole reaction, that is in the product. So we have the stoichiometric coefficient as 1, 1 plus
Yeah.
0 minus 0, so it is 1 only.
So then it'll be greater than,
yeah,
which is, yeah, great, cool. N2 gas, 3, delta U is greater than delta H, so delta H is less than delta U.
Yeah,
I think.
but what is the delta Ng in this question?
-2.
Yeah, that's right. 2 minus 4 negative 2 means delta H is less than delta U.
Okay.
Got it?
Yeah.
So I think now you can relate the both terms, delta H and delta U.
Yeah.
Okay. So I think you are pretty much clear with the enthalpy.
Okay.
Right? And now, if I'll give you a question at 300 Kelvin, a process goes from 4 atm pressure to 2 atm pressure. 4 atm pressure to 2 atm pressure, and 4 mole like this. I'm writing this. At 300 Kelvin, a gaseous process. Just right.
Gaseous.
Yeah. A gaseous process of 4 mole of gas. 4 moles of gas goes from 4 atm pressure to 2 atm pressure. Okay. Find out the del H of the process, enthalpy of the process.
Okay. So just checking if we're okay. So it's like the isobaric process again.
No, not isobaric, because 4 atm to 2 atm there is change in pressure. But you have to find, you have to find out the process enthalpy. Enthalpy formula is del. Del H is equal to del U plus del NGRT. But we are having a constant temperature. This temperature is not being changed.
Okay, so it's isothermal?
Yeah.
Okay. Okay. So how would you start this?
Okay, so as I told you, it's an isothermal process. So isothermal process, irrespective of any change in pressure, the function of enthalpy is the function of temperature. When temperature is constant, the function of constant will always be 0. So enthalpy will be 0.
So the enthalpy is equal to the function of temperature.
Yeah, and enthalpy is the function of temperature. So when enthalpy is 0, when temperature is constant, so function of constant is 0, enthalpy will be 0. That is what I told you, na, starting. For ideal gas, enthalpy and internal energy both are the function of temperature.
Enthalpy and internal energy are both the function of temperature. Yeah.
I think you got it.
I did. I'm just gonna report the function of temperature, and because the function of temperature at isothermal processes is always 0, the enthalpy is always 0.
Yeah.
At the end, this one's okay. Cool.
Have you got it?
Yes, I have.
Okay. So I have given you this particular question to understand your conceptual clarity. Because if you understand the concept, then you can directly say it's an isothermal process. Isothermal means constant temperature, and the function of constant thing will be 0.
Okay. Okay. Yeah. Yeah.
Got it?
Got it.
So I'm having a chemical reaction. Chemical reaction, reactant gives product.
Yeah.
And del H is equal to del U plus P del B. You know that? We have derived this, right? And enthalpy of product, enthalpy of reactant is H1, enthalpy of product is H2. Okay? So del H will be, del U means U2 minus U1 plus P del means V2 minus V1. You can arrange like this: U2 plus PV2 minus U1 minus PV1. It will be U2 plus PV2 minus common ले लो, it will become U1 plus PV1. ठीक है? It is del H. So del H become U2 plus PV2 means H2 minus U1 plus PV1 H1. ठीक है? So you got del H is equal to H2 minus H1, or you got HP minus HR. Enthalpy of reaction is the enthalpy change of reaction. Enthalpy change of reaction is nothing but the difference of enthalpy of product minus enthalpy of reactant.
And yeah, enthalpy of change of reaction is the enthalpy. Yeah, okay. Yes.
It is the difference of enthalpy of product minus enthalpy of reactant.
Yes. Okay.
Got.
Okay.
So this is the derivation part.
Okay. Okay. Right. Okay, cool. Okay. Got it.
Okay. Yeah. So do you have any doubt till now in the class?
I don't think so.
Yeah. So what I will do, I'll share this whole PPT with you. You can go through the PPT and enthalpy of reaction. And there is also one law that is called the Hess law. I think you would be also having the Hess law.
Yeah. So 5.2 is the Hess law, and then 5.3 is bond enthalpies.
Okay. So Hess law is all about the enthalpy.
Okay.
So I'll just explain the Hess law. Then we will finish the class. See, I'm having a process A to B. I'm having a process. In the process, final point is A and the initial point is A. The initial point is A and the final point is B.
Okay.
The final point is B. Okay, cool.
Okay.
Okay.
Yes.
So in the initial point and the final point, we are having a and B. And this process can be attained via direct this path, or you can go to A to C, C to D, and D to B. D to B. Either you
Oh,
can
yeah.
okay, either you can directly go to A to B, or you can opt the path A, C, CD, and DB. So path function will keep on changing, but the state function like change in enthalpy, change in entropy, gives free energy, all these are state function. State function value will always be conserved, will always be conserved, conserved, irrespective of path taken.
What will always state?
Irrespective of path taken. No, okay, I'm going to explain. State function means the function in which only it depends on the initial and final state of the particular process. State function doesn't depend on the path, but only the condition provided that the initial and final point in the process has to be same. If you go directly A to B, that is also a direct state, or you go to A to C, C to D, D to B. But finally, you are reaching where? You are reaching the final destination, that is B. So
Yes.
in this kind of cyclic process, state function will always be conserved. So enthalpy will be conserved. So if the enthalpy A to B is delta H and A to C is H1, del H1, del H2, and del H3. So as per Hess law, del H equal to del H1 plus del H2 plus del H3. Got it?
Kind of.
Okay, I'll explain again.
Okay.
No problem. I'll make you definitely expert in this concept. Suppose I'll give you example, chemical example, right? Suppose you have to form the CO2. C plus O2 forms CO2. Okay, and the enthalpy of this process is delta H equal to X. Okay, and then again you are forming C plus half O2 gives a CO. The del H of this process is Y, and then CO plus half O2 gives CO2. The del H of this process is Z. Okay, now you have to retain, or you have to gain the first equation. First equation is the final destination. So from you have started from carbon and finally you have reached the final destination irrespective of path. First path you are getting CO, second path you are also getting CO plus half O2, but the final destination is CO2. Can you see that?
Yes, I can see that.
Now if you add equation first and second, what will be that equation? You can cut CO and CO, both are different sides.
So delta H to Y plus Z.
Yeah, so X equal to Y plus Z, because finally our final destination is being achieved irrespective of single path or irrespective of multiple path, but we are getting the final destination as a CO2 gas molecule.
Okay, so irrespective of the path. That's
I think now you are getting some clarity about the Hess law.
Yeah.
So Hess law doesn't depend on the path, it depends on the state.
Depends on the state.
Okay.
Okay, and I just so delta H, delta entropy and everything is
State
for
function.
the state function, right?
Yeah.
Okay.
These are the state function. It doesn't depend on the it doesn't depend on the path we taken, irrespective of any path. It will always be conserved. So it doesn't depend on the path what we have taken.
Right. And entropy, what is entropy?
Okay, entropy comes from the second law of thermodynamics. Suppose you are sitting in the room, right?
Yeah.
And there are 10 friends of yours. 10 friends are sitting in the room, and suddenly you have heard, you have sensed, you have felt that earthquake is coming. Earthquake is coming. So what you will do? You and your guys starts running out of the room. You guys will seek the open place.
Yeah.
So the kind of order in the room, like the kind of chair system, the kind of arrangement system, all will be the chaotic, all will be the random, everything will be spread like anything, because you guys got feared and you have to run away, right?
Yes.
So in this
Yes.
process, what does happen? In this process, there is a increase in the randomness, increase in the chaos.
Okay. So
So
increase in random motion is entropy.
yeah, degree of measurement of randomness of the system is called entropy.
Okay.
Okay, so suppose if there are some certain guests are coming in your home, and your mama, I think the name of your mama is Pratibha, right?
Yes.
So
Fatima.
Pratibha told to Maya ki Maya, go to the kitchen and just start preparing the tea. So you will
Okay.
you will pour some liquid. By the way, how do you prepare the tea? Means you are a good tea maker or you are just an ordinary tea maker?
I think I'm an ordinary tea maker.
Okay, so you pour some water, you open up the flame. So what you see,
Yeah.
what you observe in the pot, you observe in the pot that the thermal vibration of molecule starts happening, molecules are colliding, and now molecules are converting from liquid to gas,
Yes.
right? So you see
Yes.
the random motion, you see the molecule random motion has increased.
Yes.
This is nothing but the entropy.
Okay. So it's related to pressure.
Kind of, but it is not related to pressure, it is related to the heat supplied, because there is a thermal vibration in the system. So thermal vibration means temperature, and temperature is a direct function of heat.
Okay. Okay, because heat increases random motion and speed of molecules. And yeah.
Right.
Okay.
So thermodynamics is all about the study of these kind of fundamental things.
Okay.
So now are you getting the feel of thermodynamics? That is important.
Yes, I think I'm getting an idea of what it is.
Okay, this is only important, because you can read everything from the textbook, but a mentor can can inculcate the level of interest, can inculcate the feel, and that feel is very important. Cool.
Yes. Yes.
Okay.
Cool.
Okay. So I think in a single week, how many class you want to have? You want to have 2 class or 3 class in a week?
3 is good, but actually next week I'm a bit busy. I mean,
Yeah.
I can have a class on. So next week actually is a very weird week for me.
Okay.
So I was thinking, can we have a class on maybe Tuesday and a class on Friday?
Yeah, Tuesday, Friday, next week.
Yeah, and then following that week I have a regular schedule, so we can just do any classes that is free.
Okay, cool. Okay, so next week we can have the 2 classes followed by the 3 classes in the upcoming weeks.
Yeah.
Okay, cool. If you have any doubt, you can still ask. Otherwise, I'll sum up my class and I'll share the PPT.
Okay, thank you.
Yeah,
I don't have any doubt.
Yeah, thanks a lot. Bye-bye.
Bye.
Yeah, bye.
Oh, also.
Yeah.
I was wondering if I could share my syllabus sheet just in case you wanted it.
Yeah, definitely you can share in the group. The group your mama has formed.
I'll share it there.
Okay, you share that in that group. I'll see and I will also share this stuff in the group.
Okay, great. Thank
Okay.
you.
Yeah, welcome.